Introduction, material and methods, analysis, research and discussion, conclusion. Introduction. No problem. Hospital wastewaters contain several micro and macro pollutants that must be treated first. It is processed at the wastewater treatment plant to overcome this problem. The effluent from it mostly discharged into the environment. However, the need to reuse the hospital wastewater treatment plant effluent will be a new way how to handle it in the future. And then treatment. The technology recommended for the treatment is ultrafiltration. Ultrafiltration is the most widely used membrane technology today. It has many benefits because it's used in wet applications. According to maybe I will according to research by ASFAC, ultrafiltration successfully handled one type of hospital wastewater, namely laundry wastewaters. The research found that ultrafiltration was able to provide more than 87% rejection result for parameters such as COD, TSS, and surfactant concentration. The problem is membrane pooling. It causes the permit flux reduction and the frequent physical chemical cleaning. Is pretreatment and cleaning. Both are recognized as a good ways to mitigate membrane pooling. Sedimentation and cloth media filtration will be a good pretreatment before ultrafiltration. And the use of sodium hydroxide and sodium hypochlorite also could be the best agent cleanings for cleaning membrane. Considering consider considering considering the facts mentioned, eh, the ultrafiltration membrane with pretreatment in terms of performance and cleaning. Next, the material and methods. The material used in the research is cleaning agents with sodium hydroxide and sodium hypochlorite and the hollow fiber ultrafiltration membrane. Then the schematic of the UF membrane filtration setup is shown in the figure. There is the experimental procedures. The pit water was treated with two different treatments, with treatment and without treatments. After 4 hours operation, membrane folded by the effluent. After fouling occurred, the ultrafiltration membrane was rinsed with hydraulic cleaning. Two kinds of combined hydraulic cleaning were used, backwashing and forward flushing. The UF membrane was cleaned with. After that, the ultrafiltration membrane cleaned with chemical cleaning, and we get clean membrane. Analysis. There are two analysis parameters used in this research: permeability and selectivity, as shown in the figure. Selectivity of parameter content used in this analysis is COD, ammonia, and color. Oops, actually, there are three parameter analysis, I forgot to add it on my presentation. The other parameter is cleaning efficiency. Cleaning efficiency itself has three parameters, namely flux recovery percent, pooling removal percent, and hydraulic cleanliness criterion. I can see it in the figure. Maybe I can show. Sorry. Yes. Anyone can see this is the yes. Here is my three cleaning parameters: flux recovery percent, removal fouling percent, and hydraulic cleanliness criterion. Okay, next. And, the effluent source was the wastewater treatment plant effluent of Diponegoro National Hospital, and the feed water characteristic is shown in table of parameters according to the environmental protection agency standard. Yeah, what I mean is EPA, and the Indonesian national standard from Ministry of Environment of the Republic of Indonesia. What I mean is LHRE. There is no value for the total dissolved solids on both reference for TDS. There's no value. So, but however, the hollow fiber ultrafiltration membrane has a limit for TDS, which less than 1,000. So that TDS of the feed water can be acceptable because in this feed water characteristic is 300 until 390. Then result and permeate fluxes. The following process has been carried out for 4 different treatments to the UF membrane fault by the hospital wastewater treatment plant effluent. The experiment without pretreatment has the highest flux decline rate by 29%. Meanwhile, the smallest flux decline rate is the experiment with sedimentation 7 hours and cloth media filtration by 3.3%. It is due to the accumulation of concentration polarization at the membrane surface, which can reduce the permeate flux. All of these indicate that the pretreatment with sedimentation 7 hours and cloth media filtration is more efficient for the purpose of control during the process. Removal of color, COD, and ammonia. Table 2, the removal of feed water. The removal of feed water from the effluent by the UF membrane experiment is shown in table 2, which presents color, COD, and ammonia reduction results. The color removal in table 2 shows that the enhancement of treatment stage also could enhance the number of color removal in the effluent, which also the higher removal of color is achieved by the experiment with sediment 15 hours and cloth media filtration. The effect of cloud media filtration alone was more dominant in the reduction of concentration COD. It is due to the presence of other organics. Meanwhile, the effect of sedimentation was seen along with the longer sedimentation time. I mean, table 2 also show that removal for every additional treatment only increase average of 1%. It indicated removal. Membrane cleaning, the effect table 3, the effect of pretreatment to cleaning efficiency. Table 3 shows that the membrane ultrafiltration with pretreatment gives better results than without pretreatment. It achieved also in flux recovery, 70% for fouling removal and hydraulic cleanliness criterion less than 0. It proves that treatment can maintain longer permanent gas cleaning efficiency than without treatment. Conclusion and the discussion before, we can get conclusion in this topic. The addition of sedimentation and cloth media filtration is effective to control the flux reduction rate caused by falling of the hospital wastewater treatment plant effluent. The smallest flux decline rate was shown in the experiment with sedimentation 7 hours and cloth media filtration. The highest percentage removal was shown in the experiment with sedimentation 15 hours and cloth media filtration. And the chemical solution of sodium hypochlorite 100 ppm at pH 12.6 could achieve satisfying cleaning efficiency for cleaning the wave membrane treatment of sedimentation 15 hours and cloth media filtration. Next is references used in this research, and this is the other references that we use. So that is my presentation, and thank you.
Okay, right. Thank you very much, Mahir, for your presentation. It's very great work. So I would like to have questions from the audience. We have 22 audience here. So let's give a suggestion or question to Mahir for his presentation. He's going to finish his work actually. Vinny, this is our alumni. Okay, Fabio, any question from you? Okay, Fabio.
Okay. Hello.
Yeah.
Could you hear my voice?
Yeah.
Okay.
Yeah, we are waiting for your question.
Okay. Thank you very much. Okay. Thank you for Mr. Mahir. That was interesting research. I don't even thinking about the hospital wastewater to treat into the clean water. It is the exciting one. And I have a question for you about the flux performance you have presented before. I see that the 7 hours of sedimentation resulted the what is the superb performance than the 15 hours of sedimentation. And I am wondering that how could it happen? And the other one is if we see the percent removal or rejection performance of your result, that was the 15 hours of sedimentation resulted the highest of percent removal. And how could it happen if the flux performance is the 7% is the highest flux performance, but in the removal is 15 hours? What happened of that phenomena? Could you explain to us? Thank you.
Okay, back to Mahir. Maybe you can show again the result on the flux graph.
Okay. Thank you uh, for Fabio the question. I I ex I expectation the question like this will be shown in this presentation. So uh, this is probably because the behavior of collate itself in on the feed, but I can prove it because actually the for the fact theory that the longer sedimentation, the the clean water that you get. All right, the longer sedimentation, the clean water that you get. But in this experiment, 7 hour sedimentation uh, has a great flux, has the highest flux decline rate than 15 station. Hours has 7 hours sedimentation has a great flux decline rate. Has what is it mean? I forgot. Has the yeah, the smallest flux decline rate is the experiment with sedimentation 7 hours and cloth media filtration. This is because the behavior of collate itself in the on the feed, but I can prove it because I haven't do the research for the longer sedimentation time than 15 hours. If I do the longer sedimentation than 15 hours, because I want to show the my ini. In here, I just do sedimentation 15 hours and sedimentation 7 hours. What if I do sedimentation hours plus cloth manipulation? Uh maybe I can take a solution of my problem, but so that this is need for the research, so we can take the solution of my research problem. My spelling is not really good.
Okay, maybe you can share the table number 2. Mahir, can you please could you please share table number 2? Halo Mahir. Could you please show us table number 2? The next one, table 2. Yeah, this one. Fabio, can you see the table?
Yes, yes, I could see, sir.
Yeah, I think this result I think in accordant one to the other, because as you can see here in table 2 that with the sedimentation at 15 hours, there will be more and more total dissolved solid will do settling. It will settle down due to the gravity. So you can see the color removal is higher at 15 hours. So without pre-treatment, the color is 10, and then after sedimentation at 7 hours, the color removal is 14, and then at a longer sedimentation at 15 hours, the color removal achieve almost 40%. So that will be less dissolved solid in the effluent. That's why the flux at 15 hours is going to be higher than 7 hours. So it is in accordance with the graph before. You can see maybe Mahe, you can check back on graph before this one. No, this one. You can see with sedimentation at 15 hours, the flux is higher than 7 hours. The blue,
yes.
the light yellow, the light blue with, and the gray. So it is according. This is good result,
Oh yeah, I
right?
see.
So they are in accordance. Yeah. So the longer you do the sedimentation, there will be more and more dissolved solid to settle down due to the gravity. So the wastewater should be clearer at a higher, at a longer sedimentation time. So it will result a higher.
Oh yeah, yes, sir.
Right?
Yeah, it's clear enough. Yeah. But something that still in my mind, like,
Yep.
why the flux reduction, like in 7 hours, is more slightly reduced than the 15 hours of sedimentation. That was my what is in still in my brain, like, oh, how could it happen if we think as usual, like the 15-hour sedimenter should be the most of the particulate will be precipitated, but and it could produce the what is the more slightly reduced than the 7 hours, uh, like that. So the reduction of the flux performance in 15 hours uh, is
You
lower
can
than
see in this graph, you can see that at 7 hours, the graph is almost horizontal. So the decline is smaller than the uh, the sample with 15 hours sedimentation. Right, so there is almost no change at 7 hours.
Yeah, maybe because of the sentence of the smallest spark decline rate is the experiment with 7,7 hours that make the problem, I think so.
Yeah.
Because of that sentence, so the reader try to be how why this gonna happen like that. Just okay, I think.
Actually, actually, in my research, there is no really different between 17. There's no really high difference. What I mean, between 7 hours and 15 hours. But
Yeah.
accidentally, the flux for 7 hours accidentally is more a
Yeah,
little longer than 15 hours. Maybe I will
yeah. I
show the
see it.
15 hours. It's okay.
Okay,
Yeah.
okay, okay. Thank you very much. It's so
Yeah.
clear now. Okay. Thank you,
Okay. I
Professor
think this.
Andre and Mr. Mahir.
Yes,
Thank you
Yeah.
very much.
it's
Yeah.
just little bit different.
I think this result is in accordance. Although, perhaps we have to check also, Mahir, if it is a better way, if you can show us the total dissolved solid, this one, yeah, not the COD, ammonia, and color, but I think Fabio will be preferred to have your TDS data rather than the COD or ammonia or color. Yeah, I think color might not be too might be too easy to understand whether the total dissolved solid or total suspended solid, how it will affect the color, right? Although of course the more total dissolved solid, it will also affect the color here, but it is likely that the change is not much when we use the CMF itself with the sedimentation at 7 hours. The change almost doubled when the sedimentation was done by 17 hours. So sedimentation in 7 hours is likely nothing happened. You can see the change in color only 12.5 and then change to 14. It is not really significant. But when you did the sedimentation in 15 hours, then the color removal almost double. We have here 40% removal, right? I
Yes, sir.
think what we have to do, I think I would prefer to you to do a longer sedimentation, maybe at 20 hours or 24 hours, because 7 hours itself it only result 1.5 removal, different with CMF alone without sedimentation. Because the color here, I'm very sure the color only it will reflect how the total is of solid data. Yeah, unfortunately, you didn't do the TDS or you didn't analyze the TDS on this result. Or did you?
Uh, yes, I do the TDS, but as you know, the ultrafiltration has no effect for TDS, sir. Ultrafiltration has no effect for TDS change. But if you use reverse osmosis, the TDS will change.
But if we can see here, back to table number 2, we can see here actually from your color change, meaning that when you did the CMF
Mm.
by and in combination with sedimentation for 15 hours, you have almost 40% removal of the color, meaning that the TDS removal is effective.
Mm.
So I would prefer to know as well the TDS rather than the color. Of course, color is good, but I think TDS data is much more better for environmentalists to know how the TDS in the sample after the
Oh.
treatment is in combination between the sedimentation and the cloud membrane filtration. Yeah.
Oh. Sir, in my research,
Mhm.
I always calculate, mengukur, always calculate the TDS after and before experiment, but there is no change. There's no difference between before and after treatment. for the TDS. That's what I get, sir. There's
Okay.
no different research.
Yeah, but then it was very odd because the color is changed. Because in my opinion, the TDS will affect the color because the more dissolved solid and the more dissolved solid removal in the TDS in the wastewater, and it will make the water become clearer. So you can see here the color changed. The color removal is almost 40%.
Mm.
So the color removal is, let's say, now the without treatment, you have the removal is 10% removal. And then after the CMF alone, you are
Yes,
right.
sir.
CMF alone is only
Yeah.
12.5, so there
Only
is
2.5. Okay.
right, there is no change. But when you do
Yeah.
combination between the sedimentation at 15 hours with CMF, you had almost 40%. But when you did the sedimentation only by 7 hours, there is no much change as well. So, in my opinion, I would suggest you to do sedimentation longer than 15 hours. Let's say 20 hours or 24 hours. Usually, environmentalists prefer to have 24 hours than 50 hours.
I'm sorry, sir. I hear TDS or TSS.
Uh,
TDS or TSS.
I think TDS, if TSS, because TSS of course is a big material. If TSS, it will due to the reflection. Let's say you can check only by let's say using what we call as maybe refractometer is also okay just to check the TSS, but TDS is the dissolved solid. It is in a more micro component, micro size rather than the TSS, because TSS of course is a bigger bigger particles than the membrane,
Yes, bigger particles, sir.
right? So it's always prone to the falling in the membrane is the TSS, not the TDS. TDS is later on after you are successfully remove the TSS, then the other problem is the TDS, mainly due
TDS.
to the salt, maybe calcium or natrium, etc.
Okay. Thank you, sir.
Yeah. Okay, we can check table number one. I would say something for you. Table number one. Actually, if we check on this wastewater and the standard, there is nothing, there is no problem with the waste. Why you did? Because if you check on the standard, let's say the pH, the Environmental Protection Agency, the EPA, suggests that the pH is within 5.5 to 9. So if the wastewater, the pH is 7 to 7.7, it should be okay. So no problem with the pH. Other the color as well, the EPA suggests between 20 to 150, and you found and the sample is 32 to 50. It's also no problem with the color, right?
Yes, sir.
So as well for the chemical oxygen demand, uh, the chemical oxygen demand from the Indonesian standard is 80, and then from the EPA 40, and you got from the wastewater is only 19 to 48. It's also no problem actually. The only problem might be also from the ammonia content. EPA provides a very wide range between 0.2 to 4, and your sample is 0.46 to 0.53. This is no problem actually with your waste, right? So
Mm.
actually no problem with the waste. It should be okay.
Actually, sir, this is the standard for the effluent if you wanna discharge it into environment. But
Into the water. Okay.
actually my goal is
Mhm.
the standard for this is the fit of I wanna reuse it.
Hmm?
Uh, I wanna reuse it for the RO fit gitu, sir. What I mean.
So
But there is no standard for RO
yeah, I
fit
think what
standard. So
I think what Prof. Human always looking for is how to produce the water, how to generate the wastewater into a readily used water. I mean, water that can be used in the sanitary. So what you have to do actually to compare this fit water with the water that is used that can be used for the sanitation.
sanitation.
Yeah,
Okay,
so
okay.
then only we can, because if we check on this comparison, there is no problem with your water. But if
Oh
you
yes, yes. This is the standard for discharge
standard
into
was
the
water
environment.
as the sanitation water.
Okay, okay, sir.
Yeah,
Sanitation water. The
yeah,
standard sanitation water. I
yes,
will looking for it.
yeah. We have in the Ministry of Health.
Okay, sir.
Yeah. Okay. Any other question from the audience? I think it is very good work. I saw just now, it's gone already. But Danny, do you have any question to Mahir? Again, the Annie is cooking, so I'll move to the audience. Okay, Fatma, any question from you?
Not yet, Prof.
Not yet. Okay, Kamsi? Or
Yes,
anyone?
Prof.
Yeah. Any question from you, Kamsi?
No, Prof. Thanks.
Okay. So, okay, Mbak Mia, how about you? Any question to Mahir?
Okay, Prof. Andri.
Yep.
Mr. Mahir, I have two questions for you. The first is, can I know in detail the pretreatment process using sodium hydroxide? Because I also need the information. And the other question is, did you calculate the flux using the membrane, using the ultrafiltration membrane, and how it decreases each time? Because we know that the contaminants of hospital waste are very diverse. Thank you.
Okay, Mahir.
Okay, sir. This is uh, thank you for Mia for the question. He is she is asking about I forgot about sodium hypochlorite, right?
Yeah, sodium hypochlorite.
Um, Actually, sodium hypochlorite used for membrane cleaning in here after pretreatment without pretreatment. So first the feed water will be get uh, 2 months without pretreatment and treatment, and then after that we will know that how the result is. Then after that uh, we will do uh, uh, cleaning the results where without pre-treatment has a flux recovery low with pre-treatment, whereas sedimentation 15 hours has almost 100% influx recovery. So this is so with after after I did I did pretreatment, and with the pretreatment to my membran, and without pretreatment more low has a results low than sedimentation. It is because the falling on the membran, the higher falling in more higher than sedimentation 15 hours. Is it right, the answer? I'm sorry. Mia?
So you directly dissolve this sodium hypochlorite in the
Yeah.
wastewater. So with the others
No,
process, maybe
I no, no, I don't do. I don't. Me, what do you mean is the membran I apa ya, tenggelamkan ya dalam ini sebelum dilakukan pre-treatment gitu maksudnya.
maybe you using activation
Sebelum
process.
I use the sodium hypochlorite after the process, not before process. After the process, I use it with a clean in place membran. So the sodium hypochlorite diputar istilahnya in cycling on the membran for 4 hours processing. After the treatment, I will clean it with the hypochlorite with sodium hypochlorite.
Okay.
Actually, there are several how to use sodium hypochlorite. There is before and after. Before membran use and after membran use. In this research, I did after membran use.
Okay.
Maybe it can answer the question of Mia.
And the second question, Mr. Mahir.
What I mean is, yes.
Did you calculate the flux each filtration time?
Calculate the flux filtration time. Yes.
Yes.
I always for every I will calculate the time of filtration for 1 liter. I always time of filtration. I will calculate time of the time of filtration for 1 liters. And I will do it every 10 minutes. Every 10 minutes. So this is every 10 minutes, 10 minutes, 10 minutes, 10 minutes. And the time is, this is the time for the time filtration for 1 liters of filtration.
So you have already have the data from the decrease time.
I'm sorry, Mia,
So
I
you
can hear your voice not clearly. Hello?
So you already have the decrease is time, your flux in the filtration process.
I'm sorry, I can hear your voice clearly. Maybe there is problem on my signal or there? Can you repeat it again? I'm sorry. Please repeat again the question.
Hello, Mr. Mahir.
Hello. Check.
I think enough, Prof. Andrew, because the connection is unstable in Mr. Mahir.
Okay, actually, I
I'm
can.
sorry.
Actually, I can get your question. Maybe you can repeat. Yeah, I will help you.
I'm sorry.
I help you to deliver to Mahir. What's the question, Mamiya?
We know the
The problem
contaminant
is
of
signal
hospital
only.
wastewater is very diverse.
Mm-hmm.
So, Mr. Mahir must have the data for the decrease is each time in the flux filtration. For the we know the falling is how to already in the ultrafiltration membrane.
Okay, that's the question.
Yes.
Okay, Mahir. Because
Yes, sir.
every waste, not only the waste from the hospital, every wastewater, it is very diverse in its properties, in its contents. It is pollutant diverse. So, did you check
Yes.
the decrease in the membrane flux during your experiment? Let's say every 2 minutes, every 3 minutes during the run of the ultrafiltration or microfiltration that you did in your experiment, and you check that there was a decrease in the flux of the membrane.
Mr. Mahir using 10 minutes every minutes.
Okay, during 10 minutes,
Yeah.
every 10 minutes sampling, did you found that the membrane experienced a decrease in the flux?
Yes. It decrease on the flux and on the flux. What I mean. And always this is can you see it's always, but maybe in other there is up a little bit, and then this is will go down for the flux. Always down. The flux always down because this is the effect of falling on the membrane.
Yeah, so but yeah, it is confirmed that he experienced the membrane also experiencing the decrease in the flux due to the fall membrane and the surface on the membrane pores.
Yes,
Actually, sir,
and
I have another data that, but this is not really high, but this is about backwash interval. So if I add backwash interval
Mhm.
on my research, but in here there is no backwash interval. But if I add backwash interval, there will be the flux will be up, but the backwash interval maybe after every backwash interval for every 10 minutes or 5 minutes. The the flux will be up. But in this research, I didn't add backwash and backwash interval. So it will be absolutely go down flux on the permeate flux. But if I add backwash interval, it will be up, down, up, down, up, down, up, down, up, down. Like that,
Okay.
sir.
Okay. So, Mia, experienced the falling on the membrane pore and membrane surface. However, he mentioned that if he did some intermittent back flushing, and then the flux will increase. So it's meant that the dissolved solid is likely to be physically fall, so the chemical falling. So we usually we used, let's say, the hydrochloric acid or whatever acid to dissolve the fall in the membrane, but when he did only by backflushing, and then the fall already dismantled from the membrane. So it is likely only physical interaction between the pollutant and the membrane surface.
yes. Thank you so much, Mr. Mahir and Prof. Andri.
You're welcome. Okay, it's very nice discussion. Thank you, Mbak Mia, Mas Fabio, as well all the audience in this very morning discussion. It's very hot discussion. Unfortunately, we have reached the end of this first presentation. I think we should give a big applause to Mahir for his presentation. Thank you very much, Mahir.
You're welcome, sir.
Yeah,
You too.
so good work. I think we are waiting for you to sit on your oral examinations. Perhaps, yeah, within next month if you want to finish your master in December or January.
Okay.
So we have to move to the second presenter.
Okay, absolutely, sir.
We'll move to the second presenter, which is Vinny Roma. She is going to present her research work on the study of recycling effluent hospital wastewater treatment plant with reverse osmosis. So I deliver the occasion and time to Vinny.
Yeah. Everybody can see my slide. Everything.
Yeah.
Oh, okay. Thank you for the opportunity, sir. Now, I'll present the result of my research with the title "The Recycling Influence of Hospital Wastewater Treatment Plant with Reverse Osmosis." Background: hospital is a means of health effort to carry out health service activities within carry out its function as produce. There are various types of water produced in the hospital. One of which is liquid waste. Not managed properly, it can have a negative impact on the life of living things and the environment. Research on the RO system that focus on treating wastewater from hospital wastewater treatment plant into clean water has not been widely studied. The use of reverse osmosis membrane is expected to provide an alternative process in treating influence of hospital wastewater treatment plants to obtain clean water in accordance with the regulation regarding water quality standards. System technology is widely used to water of high quality, both on a small scale and on a large scale, but this technology needs to be assessed for its use on the performance of RO membrane as filtration membrane in the recycling of the hospital wastewater treatment. Goal of research: the study aimed to examine the performance of RO technology for recycling effluents of hospital wastewater treatment. Summary overview: hospital wastewater is the water of an or activity originating from the hospital. The average value of hospital wastewater shown in table 1. We can see that the value is still high when compared to the regarding the standard of clean water quality. RO occur when pure water flow from the high concentration set to the low concentration set. The water flow or source is reversed by means of a solution that has a high solute concentration is given a pressure greater than the osmotic pressure. The process of membrane is relatively simple, consisting of feed source, feed treatment, pressure pump, and auto membrane. Material and methods. For the tool, set of RO tool set with specification as in the following pattern. For the material consists of effluents hospital wastewater treatment plants that have fast stroke pretreatment using ultrafiltration membrane and in the aqua methods discussed on RO is three steps. That is, step 1, characterization of step 2, filtration process with RO membrane, and the last, characterization of process water or the characterization. The feedwater sample was tested with TD and COD parameter. The results are recorded as CF or saturation in the feed. For the filtration with RO membrane, 40 liter of feedwater lasts for more or less 8 hours at an operating pressure of 1 bar. Every 500 milliliter of the premium sample is calculate the flux. And then for the product water steps, the product water sample was tested with TDS and COD parameter. The results are recorded as CP or solute concentration in the premium. These three steps are repeated at various operating pressure 3 and 5 bars. Analysis method for permeability, a measure of the variety of a species penetration the membrane is influenced by the number of pore, forces, pressure operated, and membrane peaks. In measurement, permeability is expressed in flux. Only the amount of permeate volume that passes through unit of membrane area in a certain time. Mathematically formulated as follows. Selectivity determined mainly by the solute to the pore size in the membrane and by which the transport of the directly proportional to the applied pressure. In measurement, selectivity is expressed in rejection, namely the percentage of the difference in the concentration of solute concentration in the feed and permeate. Mathematically, the rejection is formulated as follows. Result and discussion for characteristic of feed water in the RO process. The characteristic of feed water and product water in the RO process are shown in Table 2. Table 2 shows the concentration of TDS and COD in the effluent of hospital wastewater treatment plants decrease after being treated with the RO system. Concentration value of RO treated water when viewed from the TDS and COD parameter has met the clean water quality standard according to the Republic of Indonesian Government Regulation number 82 of 2001. The TDS parameter has met all class. Well, COD meets class 2 for a pressure of 5 bar, as well as class 3 for pressure 1 and 3 bar. So, a reverse osmosis system with a polyamide membrane can fulfill this requirement for recycling for available clean water. Reverse osmosis process performance. Permeate flux. The speed of species penetrate the membrane permeability can be affected by the operating time and the measurement. Permeability is expressed in flux. The of operating time and permeate flow can be seen in figure 3. Figure 3 indicates that increasing the operating time will tend to reduce permeate flow. This causes the increased operating time. The more the number of solid molecules that are stuck on the membrane surface, this blocking the permeate flow rate. The effect of operating the effect of permeate flow can be seen in figure 5. In figure 4, sound an increase in flow with an increase in operating. The greater applied the volume in fluid that can pass through the membrane will increase. For rejection of TDS and COD, the effect of operating on the TDS and COD rejection factor can be seen in figure 5. Figure 5 shows an increase along with an increase in operating pressure. The increased operating pressure caused the TDS and COD rejection to increase. In addition, the quality of treated water has also improved to the decreased TDS and COD. The conclusion: 1. The RO system with a poly membrane has proven to be effective in recycling effluents of hospital water treatment plant. 2. The concentration value of processed water product RO when viewed from the TDS and COD parameter meet the clean water quality standard according to the Republic of Indonesia Government Regulation Number XC2 of 2001.
I'm sorry, the slide is not moving on my screen.
And
Is there a problem?
thank you for your attention.
Okay, thank
Hello.
you. But Vinny, thank you. Yeah, I think I just realized that the slide is not moving during the presentation because I'm while waiting also do some other work here. So maybe but Vinny, could you please show us starting from the result and discussion to the end? It doesn't need to from the beginning, just yeah, this one only. 39 COD quality standard cost. Okay, next. And this is the pressure. So at higher pressure. Okay, next. This the flux at higher pressure. Okay, next.
Next on the hello. Hello.
Hello, hello too.
Hello, sir. Hello.
Okay, so this is the effect of the pressure on the rejections of the TDS and the COD. It looks similar. Rejection on COD. Okay, next. Any conclusion? Okay, so I would let the audience to have question to Bhavini here with whatever that she has presenting in the slide here. Maybe those working in membrane have any question to Bhavini?
I'm sorry, sir. Ini suddenly her laptop is suddenly has down.
Okay.
Blue screen again.
Sorry.
Let me- Ini out from the meeting.
Okay, because she's disconnected.
Yes, this disconnected. Her laptop has blue screen again.
Okay. Mm. Vinny is disconnected due to the laptop problem. Okay, so any question? Maybe the question can be directed to Mahir, yeah? Because Mahir are also working together
It's
with
okay
Vinny. So
if anyone can
maybe
direct it on me.
maybe he knows a little bit on what Vinny is doing.
A little bit, sir.
I think Vinny is going in, yeah? So Vinny, okay, right, you are in. So my question here is that on your final result, connecting the COD, your final, the last graph presenting the COD performance, the rejection performance of the COD with pressure, we found when the pressure is maybe 1 or 2 bar, it was no rejection at all. It was true.
How, sir?
Your
Sorry.
last graph, your last picture, your last figure, the correlation
Yes.
between the rejection of the COD, right?
Yes.
Okay, the rejection of the COD due to the change in the pressure. I just saw that when the pressure was about 1 barometer, it the rejection was 0. Was it true?
Yes.
Why it may happen? There is no rejection to the COD when the pressure is very low. But you report that there was rejection on the TDS when the pressure was the same at very low pressure.
Yeah, because I test in the Undip and the result that, and I don't know why. I I have tried in my lab, but the result is bad. Terus, and then I try test in Undip and the result is like that. I don't know why it's 0.
but you have to find out what is the reason. What are the reason behind this phenomenon? Yeah, of course, you will know the result due to the analysis, but whatever, you still have to find out why this phenomena could happen when the pressure was very low, there was no rejection to the COD, but it was a rejection of the TDS. Yeah, you can discuss with Prof. Newman why it could happen when the pressure was very low. You still find rejection to the TDS, but no rejection at all on the chemical oxygen demand.
Sorry, sir. You mean in slide characteristic of feed water and product water?
No, on the last figure, just before the conclusion.
Conclusion.
Just before the conclusion, there were two figures. The left one is the correlation between the pressure and the TDS rejection, and the right one was the correlation between the COD rejection as a function of operating pressure.
The increase in operating ratio, the TDS and COD rejection to hello. Hello.
Yeah. So what's the reason?
Yeah, because the greater the pressure appears, the volume of fluid that can pass through the membrane will increase. The volume of fluid that can pass through the membrane is
Okay. So any other question from the audience? We have 16 audience here. By any question by any to Vinny?
hello.
No question. Satria Adi Nugroho, any question? Mbak Mia, any question to Vinny?
No, sir.
Okay, Mbak Mia have no.
Yeah.
Mbak Mia has no question. Fabio, any question to Vinny?
No, sir.
No. So everything is clear, yeah? Or confusing? Or both?
Maybe
Okay.
because the slide is not moving in the first.
Yeah, because the set was not moving starting from the beginning. Yeah, but it's okay. I think Mafini has done everything she could, although the audience cannot get what she's trying to deliver this morning. So on behalf of this morning session, I would like to apologize for her being unable to
Sorry,
deliver.
my laptop is suddenly shut.
Yeah, because
I use my handphone.
Yeah.
Sorry.
Yeah, because Mahia have told us that Vinny is having problem with the laptop, so I think she'll be okay. And she has been trying whatever she could, although it was a minimum. But at least we have heard what she is trying to deliver. through her voice without seeing the slide. At least we have known what she has been doing so far on the wastewater treatment plant using the membrane. And in general, she is trying to reduce the TDS and the COD using the ultrafiltration membrane. And although the data was still, I think, is a lack of data, but he's done everything that he could. So it is okay. Perhaps we can have a better discussion later when she presents on his seminar hasil penelitian, maybe sometimes on next month, or we will proceed with the scheduled time, and we will announce through our group. Hopefully everyone can join her during the presentation in the seminar hasil. So although this morning we cannot share so many information with Mbak Vinny, I hope during the seminar in hasil penelitian we can have more information and discuss further with Mbak Vinny.
Amin.
Okay, so don't be sad. We still have many more occasions to discuss with Mbak Vinny and also to Mahir. I think we have reached our time to close. Okay, but we have to give applause also to Mbak Vinny, yeah? Because she is trying her best, whatever she has done. So I would like to thank all the audience that have joined this monthly postgraduate presentation this morning. And thank you to Mahir and Mbak Vinny for presenting your research work in the treatment of wastewater effluent from the wastewater hospital wastewater. Yeah, which is very rare information, mostly from industrial wastewater. And this morning we have been discussed a little bit more on from the hospital wastewater, which is very specific and unique from hospital to other hospital. So again, thank you very much. Apologize for any inconvenience caused, and we will see again sometimes on November on the next session of monthly postgraduate presentation. And don't forget, to those who are going to finish by November or December, to take next November session to present your monthly postgraduate presentation, to enable you to go further with seminar hasil and oral examination of your thesis work. And don't forget also to do further with your publication in whether in the Jurnal Nasional Terakreditasi Sinta 1 atau 2 or in the Jurnal Internasional Bereputasi. Depend on you and your supervisor choice. Okay, thank you very much. I close the session. Stay healthy and stay safe. And Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam warahmatullahi wabarakatuh. Thanks for everyone. Halo Satria.
Sahabat, Mahir.
Halo Satria.
Halo.
Halo. Kirain ente nggak ada.
Ada, aku cuma terlambat tadi tuh. Gimana kabarmu?
Alhamdulillah sehat.
Gimana
Aku di Jambi nih. Aku di Jambi, ada di Semarang.
Ngapain balik Jambi?
Ya, aku baliknya pas bulan Juli kemarin, sebelum Idul Adha.
Bukannya kemarin habis futsalan ya kalian?
Halo.
Masih di Pinito.
Ayo
Ini
Vinny.
ada Indra
Kok
aja
aku
nih
masuk?
lagi nih.
Ayo Vinny.
Jadi
Iya tadi tiba-tiba hujan terus laptopku mati. Terus aku kayak,
Kirain
berarti tadi pas PPT-nya juga mati ya? Nggak muncul
iya
ya?
PPT-nya mati. PPT nggak bergerak.
kamu jelasin tapi
PowerPoint
Oh. Iya, tapi untungnya matinya pas aku udah selesai presentasi tadi.
mana ada.
Ada Andini tuh. Andini masih aktif.
Masih.
Si Indra aja kurang nih.
Masih Mas.
Suaramu.
Eni tuh masih Eni. Gitu.
Ini tuh ada Eni.
Nggak
Ada Eni, ada Teguh.
Ada Teguh
di mute
di
ya.
Yang habis
Purwati
mihas
siapa
kemarin.
ya?
Teguh masih aktif nggak tuh?
Vin kok di
Halo
mana nih?
Teguh.
Halo?
Halo.
Mana?
Vin,
Iya.
di Jember kamu? Atau di mana?
Hah?
Di Jember kamu?
Hah?
Di
Dirimu
Jember.
di mana, Pin?
Demang atau Jember
Di
ya?
rumah.
Ah,
Cuma
Ya lah tahu di rumah.
oke. Udah lepas kos dia berarti.
Andini, halo Andini.
Nampaknya nanti bulan 11 lah atau awal bulan 11 nanti mau diusahakan. Tapi mau menyelesaikan ini dulu. Paper
Makanya
ini
maksudnya
perbaikan paper tuh belum.
gimana?
Papernya kan mau
tadi?
diperbaikin
Pak Andri
dulu.
bilang apa? Enggak, Pak Andri tadi bilang apa yang November tadi gimana?
November itu nampak katanya akhir apa ya tadi ya? Akhir November atau pertengahan November nanti monthly lagi.
Siapa? Kampret.
Khusus Vinny.
Oh, kampret ya.
Kurang. Oh, ada Teguh. Ngapa suaranya tidak timbul dari tadi? Ngapa tidak bersuara tadi? Ngapa tidak nanya? Tanyain Mbak Vini
aku
gitu.
Tuh telat tadi Mbak Vini udah aku masuk Mbak Vini sudah tanya jawab.
Gak apa-apa, ditanya aja langsung Mbak Vini.
Tanya apa Mbak Vini namanya siapa gitu.
Dihabisin aja itu Vini.
Presentasinya aja aku nggak ngikuti. Tanya apa?
Gimana mau ngikutin layar slide-nya aja nggak gerak.
Laptopnya aja mati.
Sumpah ya, ujiannya berat banget ya dari awal laptop man. Terus kira
slide-nya nggak gerak si Vini. Kupikir apa masalahnya? Apa cuma aku baik gitu kan dari awal lah gerak. Wajar lah banyak orang
tiba-tiba.
Teguh di mana Go?
Aku di lab Mas.
Oh di lab sekarang lah masih nge-lab ya?
Nggak nge-lab cuma ya ke lab aja.
Di mana di UPT lab?
Di UPT.
Ada Mas Musli enggak?
Kan di lantai 4 dia itu. Saya di lantai 3.
Oh iya.
Gimana yang kemarin kebakaran itu gimana Go jadinya? Go yang kemarin kebakaran gimana? Kebakaran kan UPT kemarin.
Lantai atas kok, bukan lantai sini.
Itu biodiesel juga?
Biodiesel. Beda dengan saya, Mas.
Itu gimana sih?
Di rumah apa?
Kok bisa
kan
itu?
Cracking, cuma minyak sawit tok.
Oh iya, kemarin kan di cracking ya.
Oh
iya.
Saya nginep kan lu, Mas, sampai.
Jadi kerosin enggak kemarin tuh? Kerosin kan paling banyak hasilnya?
Apa?
Yang banyak hasilnya kemarin tuh kan kerosin ya? Bukan bensin.
Iya, lebih banyak kerosin ya.
Nah, kan paling banyak kerosin kemarin dirimu. Kan saya lihat juga itu kemarin tuh kok banyak kerosin itunya. Tapi itu kan bukan biodiesel ya?
Bukan. Mbak Eni kok di-mute, Mbak En?
Biodiesel itu kan yang itu ya sama kerjaan Mas Musli juga itu ya?
Ini kerekam nggak nih?
Oh iya, masih
direkam nggak nih?
Masih direkam ya?
Yang